Hi, everyone. Thank you for joining today's LinkedIn Live Access Management Methodologies presented by Signal, the continuous access management platform. My name is Kristen Ditch, and I'm the Director of Product Marketing here at Signal. And in this session, we will walk through methodologies that teams can leverage in a modern access management platform. This session will build off the concepts we discussed in our last LinkedIn Live, AuthZ 101, and it's perfect for identity professionals who are tasked with striving towards least privilege standards. Please drop in any questions in the chat for a Q&A that we'll do at the end of the session. And with that, I will turn things over to Atul.
Yeah, hi everyone. Thanks for attending this second LinkedIn Live, and thanks, Kristen, for organizing this. And I'll jump right in. Just a little bit about myself. I'm CTO of Signal. Signal, as you know, is an authorization company. We're all about the latest and greatest in access management. But before this, a couple of years back, I was at Google. Working on BeyondCorp, and as you might know, BeyondCorp is the zero trust product from Google. I've always been, pretty active in the standards bodies, like right from the development of SAML, if people remember that. But more recently, I wrote a little blog, and when I was in Google, which kind of became the basis for the shared signals framework and the continuous access evaluation profile, as it's called today. I've been in the identity industry for a while now, and so I'm happy to bring the little bit of experience that I have to you in this presentation. So just to recap, what we said in the last LinkedIn Live, that access control has many different ways of doing things. All the way from access control lists to the newer centralized way of doing things, and then you have RBAC and ABAC somewhere in between. But the important thing to note is that there's no one size fits all, right? You might use each one of these wherever it's needed. For example, an access control list might still be needed in a highly secure situation where you want to manage a very, very smaller number of people who have access to the most privileged things in your company. Whereas as you go down to the right, you get more dynamic and more centralized. So any access control system is strives to be a sort of least privilege system, right? So while you're trying to do that, you want to make sure that you do not disrupt user activity. So users should not actually know that there is an access control system in place. They should just be able to do their jobs without actually having to do anything special. At the same time, the permission should be adjusted to the level where users can do whatever they want to do or they are supposed to be doing at any given point of time, but they should not have too much more privilege than that, right? And then you should be able to manage this at scale, right? You have hundreds of thousands of employees. You have maybe a similar number of contractors, partner users, and if you apply this to customers, that becomes a very large user population. So being able to manage all this, manage all the various manifestations of this at scale is a challenge, and that's sort of one of the goals of any access management system, is to let you do that. And then all the actions that you do need to be auditable, right? So that any access being granted or denied, why it was granted, why it was denied, any changes you make to your policies, all of those things need to be audited. Now, this is the slide that sort of I showed at the what's most of the presentation for the last LinkedIn Live. But let me just point out that there is these components that you see here: the policy enforcement points, policy decision point, policy administration point, policy information point, and the thing that I added, which is the access audit point. These are things that you will see in any access management system, right? They may be organized somewhat differently, as we'll see today in the different methodologies, but you'll see these components everywhere, right? And some of the names are pretty self-explanatory, so I'll explain them as we go. But this is where sort of the new content from this LinkedIn Live begins. Is you can think of access management in two broad terms, right? So one is that you have static access versus dynamic access. So what this means is that you have some pre-assigned access permissions that are not changing very rapidly. That is a static thing, or they're changing quite rapidly, and that's sort of the dynamic thing. So there is a scale here as to how static or how dynamic you can get, right? Similarly, there's another access, which is whether your system is one that provides decentralized management or one that provides centralized management, right? So what this means is that you are relying on information that is decentralized, or you're defining policies in a sort of a decentralized way or a centralized way. And how are you enforcing them? How are you making decisions about them? All of these sort of fit on the spectrum, right? And so, as you might imagine, that as you go from left to right, the management efficiency actually increases, right? So it becomes very hard for you to manage a lot of data in a decentralized fashion. If you try to centralize it, you become more efficient. And as you go from more static to more dynamic, you can be more aligned with your organization's policies, right? So no organization is a static organization. Everything is always changing. And the more you can be dynamic and adapt to those changes, actually means that your access policies are well aligned with your organization's needs, right? So this is sort of the overall sort of lay of the land that I will measure each one of these access management methodologies in. And so as we go, you'll see how each one of the methodologies fit in, right? Now, the first one is sort of a local everything, which is, this is a methodology that was in use before access management became a thing at an enterprise level, where, pretty much every application kind of did its own thing, and they didn't have any centralized administration or centralized policy decisioning or enforcement for that matter. And then so everything sort of happens within the app, right? And you'll be surprised that this is actually now making a comeback in the SaaS world, because sometimes you have these SaaS applications that maybe are not completely administered or defined. They don't have any defined policies as an enterprise, and so you end up with this situation even if you may not actually know that that's happening today, right? But it was always very common in the access control list world. And as you can see, this is sort of on the left bottom, which is it is very decentralized because every application is doing its own thing, and it is very static because you have to go into every application, make changes as needed, right? So now the more common thing, and this is very popular in what are known as the authorization frameworks, is sort of you define your policy centrally. It might be a sort of English language definition of policies that you do, but then you propagate those policies in some codified way into every application, right? So like for example, if you're using OPA, or you're using OSO, or similar things, you're basically doing something like this. You're defining the policies in English somewhere, and then you're coding them into each application, right? Where it might be your OPA or your the Rego files or Cedar files, or things like that, right? So graphically, if you want to look at it, this is what it looks like, where you have defined organizational policies. You're then going into the SaaS app, or going into your Rego files or your Cedar files, and actually making those changes. Or it might be a monolithic application where either you're making some changes to the code, or you're making some changes to database entries that are leveraged in making those access decisions, right? So this is how this policy propagation works in sort of this centralized administration only kind of world. And this is where on the efficiency scale it's a little better, because you've defined the policies centrally, but or you're defined the English language policy centrally, but it's still sort of up to every application to implement those policies, right? And so, coming to this third methodology, which is sort of by far the most commonly used thing, right? So this is the basis for RBAC and ABAC, where you are defining the policies centrally. And then what you're doing is you're translating those policies into policy information that is used by every application, right? So this policy information may be roles or groups, or it could be attributes, right? So it could be things like what is your clearance level, or what is your certifications, or things like that the application can use as attributes to make decisions about whether or not to let you access this thing. And as you can see, I've not marked any dot here because there are two variations, two big variations of this, which have different properties. And so we'll get into those as we discuss them. And so, as you can see that even with companies that use like SaaS applications and use SCIM, they also fall into this thing because you're now propagating that data into those SaaS applications from a central pit, right? And so you have a lot of support for this in terms of tooling, like IGA platforms will help you with propagating this information, managing this information, and all that, right? And so, if you think about role-based access control, which is a kind of this where you have managed your administration and information centrally, but the decisions are being made inside of each application. So your policies are now, English language policies are now getting translated into roles and groups, and then those roles and groups are centrally managed, right? And they may be looked up by the application from a central directory, or they may be propagated to different systems like SaaS using SCIM or other mechanisms, right? And if you can see that now the efficiency is better because you're making it more centralized in terms of management, but it's still very static because these roles and groups are very hard to change and maintain, right? If you want to make it more dynamic, you're going to have a very sort of very expensive kind of process, and so this is kind of is where it fits in. But when you get to attribute-based access control, right, this builds on the role-based access control methodology. What it does is instead of role being the only attribute that you look at, you can look at other attribute tags. Like you can look at a certain property of a user, let's say citizenship or residency or some attributes like that, which lets those users access different types of data. And those that data is also tagged with similar properties, like let's say this file is allowed to be viewed only by residents of the EU, and then you look for that same tag for the user, and then you decide whether or not that user is able to do it. But these decisions are still being made inside the application, right? So it's the same, you're centralizing the administration and information, but the decision is still being made inside the application, right? Now, this is much more efficient, much more dynamic, because these attributes can change much more rapidly and automatically. Because what happens is that, let's say you have to define a role for every type of file, you're going to have a policy explosion, right? So instead here, what you're seeing is basically with attribute-based access control, you don't get that policy explosion because you can define these attributes regardless of the resource or the user group or things like that are mentioned, right? So what this means is that, let's say you have 1,000 files, right? You don't have to define a role or group for each one of those files. You can just say that any file that has a certain attribute, like let's say EU residents only or something like that, right? And then you match that with the user attribute, whether that user is a EU resident or not, and then you can apply that single policy to any file, right? Whereas in a role or group based system, you would have to define these roles and groups for every one of those files. So that is why you see that there is a less of a policy explosion with attribute-based access control. But then at the same time, you end up with more things to manage, right? Now, where in the first place you had only a role to manage, now you have all kinds of attributes that need to be managed. Now, sometimes there is some automation, and the automation typically takes the form of some code. And now that becomes a problem because when your policies change, now you have to go through every application and change the code of that application, right? It's because you've now codified these access policies, this dynamism into the application, and so that becomes difficult to scale. So this is sort of just a comparison of ABAC and RBAC. Now, this is the thing that is really exciting, because this is a new methodology where you kind of outsource all the decision from the application to a central system. So in this situation, you have a centralized, everything pretty much except the policy enforcement. And the policy enforcement really cannot be pulled out of the application, because finally the user is accessing the application, right? And the application has to make the final decision about whether or not that user should be allowed or should not be allowed. Now, because now you have everything else that is outside the application, you can pretty much manage your policies very easily. You can change those policies very easily. You can apply them dynamically based on the latest data that you might have, and you don't have to make any changes to the application. Let's say if some regulations change, all you have to do is you may change your policies in your central system, right? The other great thing about this is that it also makes it easy to do real-time auditing. Now, because the application is coming back to the policy decision point, that you're going to be able to see every access. And then because you're seeing that access, you're able to now send out a log message that says, I've granted this access or denied this access, and why have I done that, right? And so, so many good things about it, and it provides consistency, continuous, context, all those things, right? So let's look a little bit more into that. So, as you can see that, there are many good things. Like I said, it's continuous, consistent, and contextual. Because what happens is that, what I mean by continuous is that, whenever the access is requested, it is at that time you're making a decision, right? You're making a decision based on the latest data, right? So if anything changes about your policies, let's say your policies that only users who have been assigned to a certain support ticket need to have, can have access to that particular customer who is identified by the support ticket, right? If that is the case, then as that support ticket assignment changes, your access is going to change, right? And so that is sort of the continuous thing. The consistent thing comes from, your each one of your applications is going back to the same policy decision point, which is making the decision. And so as long as the context is the same, you're going to get the same decision no matter which application it is, right? So it's consistent across all the applications. This is something that is, sadly lacking in RBAC and ABAC, because every application kind of makes its own decisions, right? But then the other great thing is that you can make decisions based on the context, that, hey, this user is coming from a managed device, or this user is coming from this particular location, and as a result, I'm going to make decisions about whether or not that user should have access, right? And again, it's fully audited, like I said. This is also something that can be done without coding, and I'll get into that a little bit. But let's look at it, that, at the some of the cons, right? So obviously this becomes a critical system, and if there is computational complexity in the path of making an access decision as a user is accessing the application, then you have the sort of the additional complexity of making sure that the access path becomes error free, and therefore the application can make a decision without fail. And then, because these systems are disconnected from each other, now you may end up with a little more latency than usual, right? And so these are the reasons why you may consider some other system than centralized. But I'll show how Signal addresses all of these problems. Now, just by way of comparison, obviously, we are so convinced about this centralized access management system that the entire company Signal is focused on solving the problem of access management using centralized. So you'll see that everything that I talk about here is the green on the centralized side, right? But for example, you get centralized management that gives you the best efficiency. You get continuous evaluation. If you're using RBAC or ABAC, there is the possibility of doing that, but then what you end up doing is writing a lot of custom code, and it's hard to maintain because those policies can change over time, and then you end up with having to make changes to all these applications that are doing the continuous evaluation, right? Again, all of these other things, as you can see, there are certain possibilities. Like you can do contextual decisions in an ABAC system, for example, because you can take the context as one of the attributes. But again, there may have to be some custom coding as a result of that, and that coding becomes hard to maintain, right? And the no code implementation is something very important, because with centralized systems, if you have to write a lot of code in the centralized system, then that becomes a maintenance overhead. but then you can avoid that using the Signal platform, and I'll show you how in a little bit, right? So like I said, this is why we've built Signal, right? Because we think that whatever approaches there are need to change to give you the maximum amount of efficiency, management efficiency, as well as the maximum amount of alignment to your organization, right? This is why we believe in the centralized access management paradigm. And as a result, what you can do is, because all your decisions are completely dynamic based on your systems of record, and I'll get into that, you can eliminate ambient access, right? So nobody needs to have birthright access to any data, right? You can dynamically enforce your policies as the requests come in. They can be completely context based. You can easily integrate into any application using the variety of methods that we have, and you can host this either in your cloud or a public cloud. And it's all auditable by default, right? So these are some great qualities about centralized access management that Signal embodies in its product. Now, just to take a quick look at the Signal platform. So you can think of the Signal platform as three different things, right? So from the policy information points point of view, we connect directly to the systems of record, right? So we do not expect the company or the organization, our customers, to have to create synthetic data that is specific to permissions, right? We can rely on your CRM, we can rely on your HR system, your ITSM system, and any custom sources you may have, like a device management system and things like that, in addition to your whatever information you have in your identity providers or directories, so that we can build a picture of the sanctioned enterprise activity based on that, and we pull that all into a central graph directory. So you see the central graph directory as a part of the Signal platform. And so you can think about it as a virtual PIP, right? Because having that centralized graph directory avoids some of these latency and reliability issues that may exist with the systems of record. And so every decision that is made is very simply made based on an in-memory database, which is the graph directory, which is highly efficient. We can execute queries, hundreds of queries in parallel, and so the response times is typically less than 100 milliseconds. It is typically in the few tens of milliseconds, right? So it becomes really, really fast to provide decisions to your applications, which may be a variety of systems at the top. It could be anything from a SaaS system like Salesforce, all the way down to an SSH, access to a privileged system, or even a Linux sudo and things like that, all the way to like API gateways, which you may be using for your APIs, right? So all of these things are covered using the Signal API, and you can write these policies in a very sort of human readable way, and each one of those decisions that you make is audited in real time, right? Now, just to summarize, there's a lot of good benefits to Signal. The first thing is that it enforces continuous access based on data that is updated constantly from your systems of record, right? So anything changes in your CRM, anything changes in your ticketing system, it'll get reflected in the graph instantaneously, right? And so because of that, your decisions are based on the latest data always, right? Then there is a simplicity in the access path, right? So we avoid any kind of computational complexity, because all you're doing is referring to an in-memory graph, and it's extremely efficient, is evaluated in parallel, and so within a matter of milliseconds you're going to get your answer. At the same time, it can be replicated into sort of as many read replicas as you want, and so there's no sort of single point of failure, and it becomes a really simple way of providing the resiliency that is needed to any inline kind of system. And because the graph is so efficient, you also get super low latency, like I've mentioned over here. So let's start the questions now, if you have any. So that's all I had to say. Kristen.
Yeah, thank you so much, Atul. That was awesome. Before we jump into Q&A, I'd like to plug that our State of Access Management survey is open. So you can simply scan this QR code here on your screen, answer 10 multiple choice questions about your access management programs, and then you'll be among the first people to receive this report. about what identity programs look like at different companies in 2023. It takes about 3 minutes to complete, and we would really appreciate your participation. With that, we can jump into Q&A for the remaining 5 minutes that we have. The first question, how is ABAC, which includes a lot of data to validate access decisions, different from centralized access management?
Right. No, so they share that quality that you're referring to a lot of different data in order to make a decision. So that is correct. But the difference here is that your policy decisions are in ABAC are decentralized, right? So each application may be making their own decision about how to interpret that data, right? That's one thing. The second thing is that in ABAC, you may actually be looking up just a database, like you may have a dependency on the system of record directly. And so what may end up happening is that if your system of record is slow to respond, or if it's not available, then you end up in a situation where you can't make a decision, right? The other way you can do it is actually, make replicas, and so that becomes sort of some complexity around replicating that data. And then finally, you may have to write some custom code to implement those policies. And because you have to write that custom code, it also becomes fragile, because if something changes about the policies, now you have to go back and maintain all the applications that have that custom code.
Awesome. I think this next question piggybacks off of your response to the last question really well. There were a few points in the conversation where you said that it's really good to have things outside of the application where the decisions are being made. Can you expand a little bit more if there are other points that you'd like to make about why it's good to have things outside of those applications, like the centralized access management methodology?
Sure. Yeah, that's a great question. So, I mean, it's good that, if you wanted to make the decision inside the application, it gives you a little bit of simplicity, right? Because you don't have to go outside the application for every access request, right? But there are so many benefits to doing this centrally, right? The first thing is that you can base your decision on the latest data, right? So it can be continuous in terms of its properties, right? So you don't have to worry about whether that latest data that you're trying to make decisions based on has reached the application or not, right? So if there is a SaaS app or something, it's making its own decisions, there may be a propagation problem from the data that you have to the SaaS app and things like that. You don't have to worry about all that, because by going to a PDP, outsourcing the decision to a PDP that is outside your application, you are basically able to rely on the most recent data. The second thing is, every application doesn't have to make its own decisions, and therefore your decisions are going to be consistent, right? So that is the other thing. And then finally, because you are making those decisions centrally, it becomes much more easier to manage, right, and maintain, right? Because then what happens is that if some policies change, you have to make the change only in one place. You don't have to go into every application and make those changes, right? So that is those are the advantages.
Awesome. A question about OPA, which we had mentioned earlier in the presentation. For a team that already has made investments in OPA, what are the additional benefits that I should expect if I were to move to a centralized access management method?
Yeah. So this is this is great, because OPA is a number of teams are using it and trying it out. But as you can see, we can use OPA as an enforcement point, in Signal, right? So what you can do is, there are two ways to use OPA, right? So one is you define a REGO policy inside your application, and your application is always dependent on that REGO policy to be accurate and up to date, and you have to make sure that all the data needed to evaluate that policy is inside the application and available to OPA. But the other way you can do it is that OPA actually has, we have built an integration that OPA can call out to Signal for the decision. And so you don't actually have to worry about updating your REGO policies or updating the data inside of your OPA application in order to make the latest the decisions based on the latest data. And so what happens is you can actually leverage OPA as you may have implemented it, and just add a call to Signal, and then you're able to leverage all the benefits of the Signal platform.
Awesome. And our last question, don't all architectures built around external PDPs suffer from latency problems?
What problems?
Latency problems?
Latency problems. So yeah, that's a good point. And there are some, there are two things here, right? One is, how are those calls being serviced, right? So are they being serviced, through some very complex computational paths, like going to a database and, looking at different systems and, some complex computations? And the second thing is, how close is the decision being made to the application, right? And so is there a latency of connectivity between the application and the centralized system, right? If you're able to address both these issues, then you get to very close to, a decision latency that you may have within the application. It's obviously going to be a little slower, but you can be assured with the Signal platform, because we are relying on the centralized graph directory, which is in memory, which is executed in parallel. You're going to get an evaluation performance that is extremely small, and the round trip latency from the time you make a call to Signal to back is a few tens of milliseconds. And obviously we can host this inside your cloud if that makes a difference, but we have sort of the multi-home global cloud. And so wherever you are trying to make the decision all over the world, you're going to get a response within a few milliseconds to make your access decision. So yes, it is going to be slightly slower, but is that performance significant in the access path? Probably not.
Awesome. Well, with that, we are at time. We are a minute past time. We're so appreciative of everyone joining. Thank you so much for the participation and the questions. If you're interested in learning more about Signal or continuous access management, please feel free to go to our website, signal.ai, and we would love to chat with you more about continuous access management. Thank you so much, Atul, and thank you everyone for joining.
Thanks, Kristen, and thanks everyone for attending.